the derivative is. What's the derivative of x squared plus 2x plus 3? 2x plus 2. And if the x is equal to 1, what will this be? If x is 1, what's the derivative? 4. So what is the slope of the tangent line? 4. So we already know y equals 4x plus c. How can we find the c?
Put a number.
Put a number in. Do we know a number?
1, 6.
1, 6. And so on. So let's have a look at this now. Y equals x squared plus 2x plus 3. And I'm looking here when x is 1, y will be 6. And I want this tangent line. So I know m equals dy dx, which will equal 2x plus 2, which will equal 2 plus 2, which will be 4. So y equals 4x plus c. Putting that in, I get 6 equals 4 plus c, so c equals 2. So I have my tangent line, y equals 4x plus 2. Much easier than the previous method, and more flexible, because we can use it now for any type of graph. Did you write this down? Yeah. One, two, three, four. I got my 2 science students. Do I have all my engineers? 1, 2. Who am I missing for engineers? I have all my engineers, don't I?
Yeah.
Sean, yes. Yeah, no one's wrong. Everything's fine. Bruce, Lee, Monica. Fine. And business. Yash, do we know why? Okay. Is it only Yash?
Yeah.
Oh. Okay. Right. Can I scroll down now? Yeah. Okay, let me give you one to try. Here's a cubic, something like this. Y equals, we'll say, 2x cubed plus x squared plus x plus 1. And let's call this point here 2. And I want this tangent line. Okay, I'll give you a minute. Give me the tangent line here. Got that? Okay, that should be enough time. They don't take that long to do. So first, I'd like to get the y. If x is 2, then let's see, that's 8 times 2 is 16, 23. It is 23?
Yeah.
Okay, so here we have m will equal 8x squared plus 2x plus 1. 6x squared. Calm down, calm down. Calm down. Right, which is 6 times 4 plus 1. If I use this as the x. 29. Okay, thank you. So y equals 29x plus c. If I put that in, then I can get the c. So what's that? 23 equals 58 plus c? Is that right? Yeah, so that's 34. Minus 35. Okay. So y equals 29x minus 35. That's the tangent line. Yep. Now on to the next line. So we have tangent, and I think some people might know this already. What is the line which is perpendicular to the tangent called? Normal. Yeah. So I'll draw it here. If this line is called the tangent line, then the line which is perpendicular, this line here, we call that one the normal. What's the only difference about this example? The m. So if here the m was 2, then here the m would be minus 2. And that's the only difference. It's hardly a difference. So we'll have a short one to practice. For example, find the equation of the normal to y equals x 3x plus 2x plus 1 at x equals 0. Yeah. To here? Here. How far? So you want me to scroll down? The words are opposite. If I scroll down, the picture goes up. Yeah. So you want to look up, so I need to scroll down. Yeah, okay. So scrolling down, how far? More? No, Fahad. No. You'll have to copy it from one of your friends. You have friends?
No.
Oh, okay.
Can I ask?
Yeah.
How did we get to
1 sec, sorry. How did I get what?
as a y?
How did I get which number did you say? This one here?
As
What?
a y.
Oh, here!
Yeah.
Yeah. What I did was at the beginning I told you x is 2.
Yeah.
I put 2 into the formula for y. Can you see here? And then this can give me, for x, this can give me the y. Is that the door? Can you do this example? Sean, have you done this example? What you should say now is, I'm doing it, teacher. Finish this one. Yeah, you have this. Victoria, Sammy, you have this one done? Yeah. Monica? Yeah. All by yourself today. No one beside you. No. Okay, can I do this example now?
Yes.
Yep. Okay, so first let's get the y. What would the y be? 1. M is 6x plus 2, but when x is 0. So that is 2. So y equals 2x plus c. Take this and put it in. 1 equals 0 plus c. C equals 1. So we have y equals 2x plus 1. No! Look, you see, you're all sitting there going, yeah, and then yeah, and then yeah, and nobody told me what was wrong here.
Don't believe the normal.
Don't blame you!
Don't believe normal.
Oh, don't believe you. Okay, well that's fair enough, yeah. Because it's a normal, it's perpendicular. So instead of being 2, the slope is minus 1 over 2. Minus 1 over 2. So now I have y equals minus 1 over 2x plus c. Now I can put the point in, and I'll get 1 equals 0 plus c, so c equals 1. So y equals minus a half x plus 1 is the answer. Yeah, you got that? Yes. Okay. Can I scroll down a bit? Yeah? What's your question, Sean? You can ask me.
I think C is the same number.
As what?
We only change the M.
Yeah. The C is the same. I got 1 last time, didn't I? Yeah. The C
I
didn't.
think we only change the M.
Yeah.
And the trigonometer C is equal.
Oh.
Right?
No.
No.
No. The reason it was equal here is because I had an x which is 0, which meant that it didn't count to the value of c. But no, good question. The c will be different for the tangent line, and the m will be different. It's just in this example, it's the same. But I'm sure that's what he would have told you as well, right? He would have said the same thing? Okay. You sure?
Yeah.
Okay. Now, can I scroll down now? Yeah. Okay, so why are tangent lines useful? Let me give you one example why. So let's take something like what would be a good example? We'll take something like y equals ex. And I want the tangent line, let's say, at 0 again. So I have dy dx, which is the m, that's equal to ex, which will equal e0, which will equal 1. So y equals 1x plus c. If x is 0, what's y in this graph? Yeah, 1. So now I have 1 equals 1 equals 0 plus c. So what does c equal? 1. So I have y equals 1x plus 1. Or in other words, y equals x plus 1. Let me just draw that in. Now, one useful feature of tangent lines is that you notice that when I look at the graph, there's not much difference between the two. Of course, they're different here, they're less different here, and then they're very different out here. But if I'm near 0, the differences are small. Let me show you. If I'm here, let's say I'm at x equals 0.1. On your calculator, if you calculate e power 0.1, or if you calculate 0.1 plus 1, the answers should be similar. This is 1.1, and then what's e power 0.1? You see that they're close.
Yeah.
This is one use of tangent lines. In other words, tangent lines are roughly equal to the curve, especially if you're close to the point where it's a tangent. So it's just one reason tangent lines are useful, because the tangent formula is simpler than perhaps what the curve is. Yeah. This is quite common in chemistry, biology and physics. So if you have a graph and maybe it's some relationship between whatever, reaction rate, bacteria, voltage, whatever it is, y and x, and the graph might look something like this. Quite often a straight line can be used instead, and as long as your values are quite small in this example, then there's not too much of a difference between the two. So the physics students, the example that we had was with the resistance V and I, and remember V, I, or is V over I. So the graph will look like a constant slope, but then I said it then changes later. And then for biology students, a good example with this would be when you're looking at something like pH level and maybe the bacteria growth or something like this with the bacteria. Maybe you get a graph that looks like this. So what you could do is you could draw a tangent line here, and for values between this and this, the line would be a reasonable approximation. And finally, for the business students, what have we got here? Quantity and price, and you have your graphs like this, yeah? But of course in real life it doesn't look like this. It might be something more like one could be like this and one could be like this. But again, if you use tangent lines, you could simplify the problem. Now you don't get the exact right answer, but the problem is much easier. It's worth the small mistake. Okay, so this is just one reason why tangent lines are important. So they're not too difficult. We'll do some examples now and then we'll go on to the next lesson. So if you look at your workbook, I don't think I have too many here. One, two, three, four. Two kinds.
One.
Yeah. Yeah, don't do those, do all the other ones.
What?
I'm just joking. 1, 2, 3, 4.